physicists treat the physics world with experimental proofs of what Einstein called spooky action at a distance. This presentation is a brief introduction to special transformation bridge, which is a part of special transformation. This study may help unify the theories of quantum mechanics and relativity. Einstein's theory of relativity and the theory of quantum mechanics are two important pillars of modern physics. On the way of achieving a theory of everything, these two theories must be unified. This has not been achieved as of today, since the phenomena of both theories can hardly be observed simultaneously. A typical example of a quantum mechanical phenomenon is entanglement. This means that the measurement of one of a pair of light particles, so-called photons, defines the state of the other particle immediately, regardless of their separation, which Einstein's relativity had not allowed. High accelerations, on the other hand, can best be described by the theory of relativity. The principles that govern the quantum states ought to be the same that governs the universe. That means laws of physics must be the same in all states. Introduction to Special Transformation Bridge. A presentation by Kishockkanthan Sivapragasam. Special transformation bridge is a new idea that explains a space-time connection that exists between dimensions as a shortcut across two different points in space-time. The special transformation bridge comes into existence between the third and fourth dimensions and connects future and present in space-time, which transforms massless particles, wave-nature particles, from the physical world to the non-physical world. The special transformation bridge exists when a body travels at a high speed in the opposite direction to the direction of expansion of space. During this transformation, when the body travels in the opposite direction to the space-expanding direction, the mass particles of the body is forced by unknown energy, dark energy, to prevent exceeding the cosmic space boundary. As a result, the two specific points in space, the starting and ending points of the transformation, get folded and curls upon itself. This means the bridge connects the two separated points in space at a singular space point through the fourth dimension. When a force is implied on a body to move in the opposite direction to the direction of expansion of space, space gets folded. To reach a point beyond this folded space, the particles of which the body is made of would get parted into two groups, particles with mass and particles with no mass. Particles with no mass also refers to particles that travel in form of waves. The particles with mass take a round trip, while the particles with no mass take a shortcut to reach the defined space point through the transformation bridge. This reveals the space-time connections between the nature of physical existence in the third dimension and non-physical existence in the fourth dimension. During this transformation, both groups of the separated particles deeply share a mysterious connection. By entering the special transformation bridge, nature opens a pre-existence of future reality. At the end of the transformation, when the spacepoint that is once folded upon itself at a singular spacepoint would become straightened, and both groups of particles meet at the same time on the other side of the transformation bridge, transforming into a single existence. That relationship between the two groups of particles can be termed as bizarre bonds between particle twins. Understanding this strange simultaneous occupancy of the body in two different places and the other phenomena induced in the special transformation study lead to a new concept in physics. The phenomena explained in the special transformation bridge are already well identified in quantum mechanics with various experimental proofs. Quantum mechanics addresses this special phenomenon as quantum entanglement. The phenomenon of quantum entanglement, which had no counterpart in classical physics or Einstein's theory of relativity, is an important consequence of the science world. In quantum mechanics, the entanglement is a strange phenomenon in which two quantum particles become so deeply linked that they share the same existence. When this happens, a measurement on one particle immediately influences the other, regardless of the distance between them. Einstein and others considered such behavior to be impossible, as it violated the local realist view of causality. Einstein referred to it as spooky action at a distance, and argued that the accepted formulation of quantum mechanics must, therefore, be incomplete. Later, however, the counterintuitive predictions of quantum mechanics were verified experimentally. Experiments have been performed involving measuring the polarization or spin of entangled particles in different directions, which by producing violations of Bell's inequality, demonstrate statistically that the local realist view cannot be correct. This has been shown to occur even when the measurements are performed more quickly than light could travel between the sites of measurement. There is no light speed or slower influence that can pass between the entangled particles. Recent experiments have measured entangled particles within less than 0.01% of the travel time of light between them. According to the formalism of quantum theory, the effect of measurement happens instantly. Einstein felt something must be missing from the quantum math if it could make no prediction about either particle until its distant partner had been measured. The theory cannot be reconciled with the idea that physics should represent reality in time and space, free from spooky actions at a distance, Einstein wrote to his friend Max Born in 1947. Einstein later emphasized that quantum mechanics described the observable realm of nature correctly. I will not deny that this quantum theory represents an important, in a certain sense even final, advance in physical knowledge, he wrote in a manuscript he sent to Born in 1948. Einstein just believed that eventually some deeper theory, incorporating quantum mechanics, might come along that would restore real values to all possible measurements on an entangled particle. He wanted a theory that, in his words, would accommodate independent existence of the physical reality present in different parts of space. When I consider the physical phenomena known to me, he wrote, I still cannot find any fact anywhere which would make it appear likely that requirement will have to be abandoned. But had he lived another decade, he might have changed his mind. This new perspective of understanding space-time explained in the special transformation bridge may solve Einstein's and Niels Bohr's argument and unify quantum mechanics and the theory of relativity, altering our radical insight into the interplay of space-time and reality. Note, a body causes curvatures in space not only due to the mass of the body but also due to the speeds it travels. The curvature that a body causes when traveling in the same direction in which space is expanding forms a gravity wall, which idea will be explained under the caption of Special Transformation Tunnel. The transformation tunnel reveals the possibility of a body traveling backward in time. We can't solve problems by using the same kind of thinking we used when we created them. Albert Einstein. Thank you for watching.